So, good afternoon my dear students. So today in this sessions we are going to learn the next problem, okay, on the taper bar. So as shown a taper bar. The taper bar of a circular cross sections area is given as 3 centimeter square and 2 centimeter square at their end, okay, and the length of this taper bar is given as 100 mm. It is subjected to a axial load of how much? 50 Newton is acting at the smaller end of the taper bar, okay, and fixed at the larger end. So this means that the larger end of the taper bar is rigidly fixed and smaller end on which the tensile load is acting at the smaller end. This is the smaller end and this is the larger end of the taper bar, okay dear. And the modulus of elasticity and Young's modulus value is given as 2 into 10 power of 5 Newton per mm square. Let us see this figure. This is larger end of the area. It is given as 3 centimeter square and the smaller end of the taper bar is given as area is 2 centimeter square. As well as the total length of this taper bar is given as 100 mm, as well as from the larger end, from top of the larger end to the middle portion, the length is given as 50 mm. But our intention is that this taper bar I am converted into the stepped bar. Our intention is we want to convert this taper bar into the step bar. Then how to convert? Let us see this figure. This is a fixed end. This is a fixed end. From here to here, this is the large end. It is considered as element 1. This is the first node, second node, third node. First node, second node, third node. The joining the first node to the second node, the forming of element 1. The joining the node from second node to the third node, the forming of element E2. Clear? Let us see. If first of all, what we need to find out? We need to find out the average area. We need to find out. How to find out? Average area equal to area of the larger end plus area of the smaller end by 2. Area of the larger end, it is given as 3 centimeter plus area of the smaller end of the taper bar is given as 2 by 2. Then you will get 2.5 centimeter square of the average area of the taper bar. After that, first of all, we need to find out the mean area of this first element and mean area of the second element. We need to find out. If you want to find out the mean area for the first element, AMI, M nothing but mean, A is indicate area, 1 is indicate first element. Mean area of the first element equal to larger end plus average area by 2. Larger area plus average area by 2. So you can remember like this, A1 plus average by 2. Okay. So area, how much is their area? First area is given as 3. Average area is 2.5 by 2. Then you will get the value is 2.75 centimeter square. So if you want to convert in millimeter square, just you need to multiply by 1000. Okay dear, again you will get multiply by 100, then you will get 275. Clear dear? After that, the same concept we need to follow here. for element 2. So the mean area for the second element, the same formula, mean area for the second element is equal to area of the second element plus average area by 2. So A2 of the smaller area, A2 how much we know it here, A2 is 2 centimeter. 2 plus average area is how much is there, 2.5 by 2, then you will get 2.25 centimeter whole square. If you multiply 100, then you will get 225 millimeter square. Clear? After getting the mean area of the first element as well as the mean area of the second element, after that we have to go for step number 1. The step number 1 we know very well, the finite element model for a given continuum is we have to represent this whole the body in this form. Let us see this body. This is the first node, second node, third node. The joining from first node to the second node, the forming of element E1. The joining the node from the second node to the third node, the forming of element E2. Clear? This is the first node, second node, third node. The length from the first node to the second node, what we can say, L1. The node joining the node from the second node to third node, what we can say, length L2. This is the length L1, the length L2. Okay. And Q1 what represent? The Q1 is represent the nodal displacement is acting at a point of 1. The nodal displacement is acting at a point of 2. The nodal displacement is acting at a point of 3. Clear? After that we need to find out the elemental stiffness matrix for the first element. Okay, K1 is equal to A1 E1 by L1, 1 minus 1 minus 1 1. A1 is how much we know very dear? A1 is 275. This A1 what they indicate? This mean area of the first element. AM1 we can say. What we can say? AM1 275 into modulus of elasticity or Young's modulus value, how much is there? 2 into 10 power 5. Length of the first element is how much is there? 50. 1 minus 1 minus 1 1. If you divide the whole the value, so otherwise dear, please represent instead of A1 AM1. Don't be confused. Okay. If you divide the whole the value, then you will get the answer is 11 into 10 power 5. 1 minus 1 minus 1 1. After that, this 11 we need to multiply to the 1. 11 1 11, 11 1 minus 11 minus 11 11. So this first element, it lies in between the node, first node, second node, first node, second node, first node, second node. For element number 2, K2 is equal to A2 E2 by L2, 1 minus 1 minus 1 1. Same concept we have to follow. AM2 you can represent area, mean area of the second element is 225 into modulus of elasticity or Young's modulus is 2 into 10 power 5 by the length of the second element is 50. 1 minus 1 minus 1 1. If you divide this whole the value, then you will get 9 into 10 power 5 1 minus 1 minus 1 1. After that 10 power 5 as it is, just you need to multiply 9 1s are 9, 9 1s are minus 9 minus 9 9. After that we need to find out the global stiffness matrix. If you want to find out the global stiffness matrix, we know very well, because already we found the value of K1 and K2. Just we need to add K is equal to K1 plus K2. K is global stiffness matrix equal to 10 power 5. This is the value of elemental stiffness matrix for the first element. This is the value of elemental stiffness matrix for the second element. After that 10 power 5 as it is, we have to arrange the node in the systematic order, first, second, third, first, second, third, first, second, third. After that we need to multiply the first node to the first node. How much will get? 11. First node to the second node is minus 11. First node to third node is available here? Not available. If it is not available, it will be considered as 0. Second node to the first node is minus 11. Second node to the second node is 11. Second node to the second node is how much here? 9. Here second node to third node is available here? Not available. Just you need to neglect this component. You have to go for this one. Okay. Okay, dear. Second node to the third node is how much? Minus 9. Okay. third node to the first node is available here? Not available. If it is not available, it will be considered as 0. Third node to the second node is how much, dear? -9. Third node to the third node is how much? 9. Again, this 11 minus 11, 0 minus 11, 11 plus 9 is 20, minus 9, 0 minus 9 and 9. So we got the value of global stiffness matrix K. After getting the value of global stiffness matrix, we need to find out the nodal displacement Q value as well as the nodal force value. Let us see, we have how many nodes? First node, second node, third node. So that's the reason I am represent here. This is the first node, second node, third node, on which the nodal displacement is acting at a point of 1, the nodal displacement is acting at a point of 2, the nodal displacement is acting at a point of 3. Clear? And then F is equal to F1, the nodal force is acting at a point of 1, the nodal force is acting at a point of 2, the nodal force is acting at a point of 3. So here, if you observe this figure, let us see this figure. Okay, this is the force. Any force is acting at this component, no force is acting at the first node, so it become as 0. At the middle portion, any force is acting here, no force is acting, it will become as 0. At the node 3, how much force is acting? 50 Newton force is acting. Okay, 50. First node, second node, third node. After that, we need to find out the equilibrium equation for the given continuum. KQ equal to F. K is how much, dear? K nothing but the global stiffness matrix. We know that much value, we got it here just now here. And Q nothing but this Q1, Q2, Q3, and F nothing but F1, F2, F3. So generally we know very well, node 1, how is it here? Node 1 is fixed. The Q1 value should be 0. Then for that reason we need to eliminate this first row into this first column. Then remaining terms should be 10 power of 5, 20, minus 9, 9, Q2, Q3 equal to 0, 53. So after that, we need to go for apply the boundary condition with the help of elimination approach method. 10 power of 5 as it is, same procedure you need to follow here. Just you need to multiply this row into this column. Okay, as well as we have to select this first one. 10 power of 5 as it is, 20 into Q2 minus 9 into Q3 equal to 0. So if you divide the value 0 by number, 0 by 10 power of 5, it becomes as 0 only. 20 Q2 minus 9 Q3 equal to 0. It is considered as equation number 1. After that, similarly we need to follow for the second equation. Just you need to multiply second row into this third column, second row into the first column, minus 9 into Q2, okay, 10 power of 5 as it is, minus 9 into Q2 plus 9 into Q3 equal to 50. Okay, minus 9 Q2 plus 9 Q3 equal to 50 by, if you divide this value, 10 power of 5. If you divide 50 by 10 power of 5, it will become as 5 into 10 power of minus 4. It is considered as equation number 2. So equate the equation number 1 and 2. Equation number 1 is 20 Q2 minus 9 Q3 equal to 0. Minus 9 Q2 plus 9 Q3 equal to 5 into 10 power of minus 4. This plus and minus will be cancelled. The remaining should be 11 Q2 equal to 5 into 10 power of minus 4. Q2 equal to 5 into 10 power of minus 4 by 11. Then you will get the value of Q2 is how much? 4.545 into 10 power of 5 mm. After that, after getting the value of Q2, just you need to substitute in the equation number 1. The equation number 1 is 20 Q2 minus 9 Q3 equal to 0. Okay. So if you substitute the value of this Q2 in this equation number 1, then you can easily get the value of Q3. Okay. So let us see 20 as it is. Q2 means how much? 4.545 into 10 power of 5 equal to 9 into Q3. If you divide the here, then it becomes as 9 divided by 9. Q3 equal to, if you divide the whole the value with the help of calci, then you will get the answer is 1.01 into 10 power of minus 4 mm. After getting the value of Q1, Q2, Q3, again we have to find out the value of stress for the first element as well as stress for the second element we need to find out. First of all, we need to find out the strain for the first element. E1 is equal to B1 into Q. The B1 nothing but 1 by L1 minus 1, Q1, Q2. So 1 by length of the first element is how much is there? 50 minus 1, Q1 value is how much is there? It is a fixed end at the node 1 is 0. Q2 is how much? 4.545 10 power of minus 5. Just now we got it. So after that 1 by 50 as it is, just into multiply minus 1 into 0 plus 1 into 4.545 into 10 power of 5, then you will get the answer of 9.09 into 10 power of minus 7. After getting the value of strain of the first element, the similarly we need to find out the value of stress for the second element, first element. Stress sigma 1 is equal to E1 B1 into Q. E1 value is how much is there? 9.09 into 10 power of minus 7. This E value is how much is that here? 2 into 10 power of 5. If you multiply this whole the value, it will become as 0.181. The unit of stress is Newton per mm square. After getting the value of stress and strain for the first element, after that we need to find out the stress and strain for the second element we need to find out. Strain E2 is equal to B2 into Q, 1 by L2 minus 1, Q2 and Q3. 1 by 50, length of the second element is how much is there? 50 minus 1, and the Q2 value already we find how much? 4.545 into 10 power of minus 5, and Q3 value is 1.01 into 10 power of minus 4. 1 by 50 as it is, just need to multiply minus 1 into 4.545 into 10 power of minus 5 plus 1 into 1.01 into 10 power of minus 4. If you divide the whole the value, it will become as strain is 1.111 into 10 power of minus 6. After getting the value of strain, then we need to find out the value of stress. Sigma 2 is equal to E2 into B2 into Q. E2 is how much? 2 into 10 power of minus 5. E2 value is how much? 1.11 into 10 power of minus 6. Just you need to multiply the value of 2 into 10 power of 5 into 1.111 into 10 power of minus 6. The value should be 0.2222 Newton per mm square. So after getting the value of sigma 1, sigma 2, and after that we need to write down the result. The nodal displacement at Q1 is how much is there? 0, because of it is a fixed end. Q2 already we have find with the help of procedure. Q2 is how much? 4.545 into 10 power minus 5 mm, and Q3 already we have find how much? Q3 is 1.01 into 10 power minus 4 mm. Again the stress and strain we need to show here in the result. Strain for the first element is how much we got here? 9.09 into 10 power minus 7, and stress for the first element is 0.1818 Newton per mm square, and for the strain for the second element is 1.111 into 10 power minus 6, and the stress for the second element is 0.2222 Newton per mm square. I hope so no one is having the doubt regarding the up to this session. Okay, so if you have a small doubt regarding this session, please write down in the comment box. Please don't forget to subscribe my channel. Thank you.